This is the start of Unit 8, and we're going to be talking about sequences. So let's write the word sequences here. Sequences. And 8.1 deals with understanding and using arithmetic sequences. So that's how we pronounce that word right there, arithmetic in this case. It's an adjective. So the warm-up here says, what does the italicized word mean in the context of these sentences? So it says, he could not get the lock undone until he put the numbers in the right sequence. Well, if you've worked with a combination lock before, you need to get the numbers in the right order. So let's write the word order right here. So when we're talking about getting things in the right sequence, we're talking about having them in the right order. And then it says she scored a goal in 4 consecutive games. Well, 4 consecutive games would be 4 games in a row. So in a row. So when we talk about consecutive, we're talking about things that come one after the other right in a row. Now, a sequence is a list of numbers. If we put it really simply, it's just a list of numbers. Any old list of numbers would do, but we're usually talking about ones that are produced by a formula and they come in a particular order. And this is kind of a more formal definition of what a sequence is. So a sequence is a function whose domain, so the things we plug in, is the set of consecutive integers. So integers that are right in a row, starting at the number 1. Unless we're told otherwise, the first thing that we're going to plug into this little formula or this little function is a 1. Now, each individual entry in the list is called a term. So we call them terms of a sequence. And each term has a counter, and that counter is called an index. And these are going to be really important because the index tells you it's the number that you plug into the formula to get the value of the term, and it keeps track of what term you're on. So here are some examples. Now we could say this one is a sub 1, and this would be b sub 9 and c sub 52. These are little subscripts. They're written smaller and down below, but we normally just say a1, and in this case a1 would represent the first term because we plugged in a 1. And then b9, that would represent the 9th term, and c sub 52, or just c52, would represent the 52nd term. And then a sub n, or an, that would represent the nth term. Now that sounds really weird, but that's what we call it. That's kind of a general term. We can talk about any one by saying it's the nth term. Okay, it's just kind of the general one. Okay, so let's come down here and let's take a look at some examples and see how this works. So on this example, it says list the first 4 terms given by, and in this case we've got a sub n, so this is what we call an nth term, or a general formula right here. And you'll notice that the index goes in both cases because it keeps track of which term we're on, and it's also the number that we plug into the little rule. Now what we're going to do is we're going to write this in what we call expanded form. So let's write the word expanded right here. And we're going to figure out what A1 is, what A2 is, what A3 is, and what A4 is. So in order to figure out what A1 is, we literally just plug in a 1 right here. So this would be A sub 1 is equal to, so we put a 1 right here and we put a 1 right here. So this would be 2 times 1 plus 5. So this is 2 plus 5, so this is going to be a 7. So then we're going to plug in a 2. So we put a 2 right here and here. So this is going to be 2 times 2 plus 5, that's going to be 4 plus 5, so that's going to be a 9. We're now going to plug a 3 into the formula, so this is going to be 2 times 3 plus 5, so that's 6 plus 5, that's going to be 11. And then you can kind of see what's going on here. You think the next one's going to be 13. Let's just double check and make sure that it is. So I'm going to go ahead and write that we would put a 4 right here and put a 4 right there, so this is going to be 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 is indeed 13, so we got that one right. So let's take a look at this next one. We're going to use the formula b sub n equals negative 3n plus 1. So here's what I'm going to write down. I'm going to write down b1, b2, b3, b4, and then I'm going to do some work down below, and then we're going to write the answer over here. So here's what we do on this one. We're going to put a 1 right there, and that means we're going to put a 1 right here. So b sub 1 would equal negative 3 times 1 plus 1. So that's going to be a negative 3 plus 1. So that's going to be a negative 2 for the answer there. So I'm going to put a negative 2 over here, and then I'm going to put a comma. And now we're going to figure out what b2 is. So the index is 2, so I put a 2 right here and a 2 right here. So b sub 2 is equal to negative 3 times 2 plus 1. Negative 3 times 2 is negative 6 plus 1, so that's going to be negative 5. So I'm going to put a negative 5 right here. Put another comma, and then we're going to figure out this one. Now, instead of writing down the b sub 3 here, I'm just going to plug in a 3 here. So we get negative 3 times 3 plus 1. That's negative 9 plus 1, so that's going to be negative 8. So I'm going to put negative 8, negative 8 right here. Put a comma, and now we've got the last one. So this is going to be negative 3 times 4. We just plug the index right there, just like we have every single time. and then we add 1. Now, you might be able to guess what's happening here. We're going down by 3 every single time. So this is going to be negative 12 plus 1, so we get negative 11. Okay, now it said write out the first 4 terms, so we got the first 4 terms here. We've got the first 4 terms right there. And then let's do this one right here. Now you'll notice this one is written slightly different, but we can go ahead and deal with that one. So we're going to do C1, C2, C3, C4, and then we'll write the answers over here. So I'm going to plug in a 1. So this is going to be 15 minus 5 times 1. So that's going to be 15 minus 5. That's going to be a 10. So I'm just going to write a 10 over here. Speed up the work just a little bit. This is going to be 15 minus 5 times. Again, we're plugging in that index there. So times 2. So this is going to be 15 minus 10. So that's going to be 5. And then we're going to do 15 minus 5 times, plug in the index of 3, because that's what the formula said to do. And we end up with 15 minus 15, so this one's a 0. And then again, can you make a prediction of what's going on here? You might guess what that next one is, but let's check and see. 15 minus 5 times, plug in the index of 4, so this is 15 minus 20. We end up with negative 5. So there are the first 4 terms of each one of those. So I'll go ahead and circle that, and then we're all set there. Now, the cool thing about this is you can get any term you want by plugging in the index. All we need to do is plug in the index. So if you want the 51st term, you plug in a 51. If you want the 97th term, you plug in a 97. So again, those formulas go by several names. We've mentioned a few of these. So we call it a general formula. We also call it an explicit formula, and like we mentioned before, we call it an nth term formula. So we'll use these 3 phrases or these 3 vocabulary words kind of interchangeably here. Now, there's another type of formula that can be useful even if it's not as convenient as an nth term formula, and it's called a recursive formula. So write the word recursive. Recursive formula. And what a recursive formula does is it uses previous terms to define the terms that follow it. And because of this, a recursive formula always has to give you a couple of things. So the first thing is it's got to give you a starting place. In other words, it's got to give you a first term. It's got to give you some place to start. And then it's got to give you a formula to get from one term that you know to the next term in the sequence. So what we're going to do on this one is we're going to do the same thing we did up above, except for this is what a recursive formula or a recursion formula, you'll hear it referred to both ways. A recursion formula looks this way, and it's a little bit uglier. So we've got this first term right here. So a sub 1, the a1 is just a 7. So I'm going to put a 7 off to the side right here. So we've got that one. And then here's the recursion formula. And notice where the index occurs in this formula. So the index, the term that we want, would go right here, just like we did before. Like if we want the second term, we're going to put it right here. So if I want a sub 2, then I put a 2 right here, and then I've got to have a 2 plus, and then I've got a sub n minus 1. Well, if I put a 2 right here for n, then I need to put a 2 right here for the other n. So this is going to be 2 plus, and then I have a sub 2 minus 1. Now take a look at what happens here. This is a sub 2. This is 2 plus. This is a 2 minus 1. It's like we're doing a little bit of arithmetic down here in the index to figure out which term we're on. So this is 2 minus 1. This would be 1. So this would be a 1 right here. So what this is saying is the second term is 2 plus the first term. So this would be 2 plus 7. So we end up with a 9. So I'm going to put a 9 right here. Now, when you look at this, one way to think of the index, you can think of it, well, it's the term that you're on, or it's the term right before the one you're on. So this is the next term, and this is the one before it. So if we were on the nth term, this is the n minus 1 term. That would be the one before it. If that was a plus 1, then it would be the one after it. And there are formulas that work like that. So we've got this one here. We've got this one here. Now let's find the third term. So if you want to find a sub 3, here's what you've got to do. The formula says if you put a 3 right here, we write down the equals, we write down the 2, we put the plus, and then we do the a, and then we put a 3 here and a 3 here. So this is going to be 3 minus 1. So this means that a sub 3, the third term, is 2 plus, let's see, 3 minus 1, that would be 2, a sub 2. So that means we're going to take 2 and we're going to add it to the second term. So that's going to be 2 plus, the second term was 9, so we end up with 11. So the next one is 11. Now you can guess that the next one's going to be 13, but let's just check and make sure that it's 13. So this is going to be a sub 4, and let's see if we can speed this up just a little bit. If this one's a 4, this one's going to be 1 less than that. So this is going to be 2 plus a sub 3. that means the third term. So we're going to have 2 plus the third term of 11, because remember the third term was 11, and we do indeed end up with a 13. Now, recursive formulas are a bit of a pain. Let's do one more here so we kind of get the hang of it. It says find the first 4 terms given by a sub 1 is equal to 10, and then a sub n equals a sub n minus 1. So notice it's in a slightly different order, and then minus 5. And it says for n greater than 1. Now, sometimes they include this right here. If not, it's just kind of understood that once we figure out what the first term is, this formula right here, this recursive formula or this recursive definition or the recursion formula, as we say, it only works if you plug in something bigger than 1. So that means you'd have to start by plugging in a 2. So we're going to do a sub 1 is equal to 10. So I'm going to come over here and put a 10. And then a sub 2 would be, let's see what we get here. That means if we put a 2 here, we put a 2 there. So if this is the second term, this is the one before it. So that's going to be the first term minus 5. So this is going to be 10 minus 5. So we end up with 5. So I'm going to put a 5 right here. So the next one, if I want to find the third term, so I'm putting a 3 in here and I'm putting a 3 in here. So if I want the third term, I need to take the second term. So this is a sub 2. Notice how this is 1 less than that one right there. And then we're going to subtract 5. So the second term is 5 minus 5. We end up with 0. So I'm going to put a 0 for the third term. And then hopefully you're seeing what the pattern is here. If we want the next term, we take the one before it. So this would be the third term, and we subtract 5 from it. So this is going to be 0 minus 5. So we end up with negative 5. Okay, so there are the first 4 terms that come from that recursive definition. Again, they gave us a starting point, a first term, and then they gave us a way to get from one term to the next term. Now, again, recursive formulas, they're a bit of a hassle because if we have to get all of the terms in order until we get to the one that we want. So we couldn't just skip to the fourth one or skip to the third one. We had to get the first one, the second one, the third one, and the fourth one, and then the fifth one, and so forth. So if you want the 50th term in a sequence, you have to get the other 49 terms first. You have to get A1 through A49 before you can get to the 50th one, because you need the 49th one to get to the 50th one. Okay, let's take a look at the other side. So after all of those sequences that we wrote down on the other side, have you noticed anything about all of those sequences? Have you noticed a pattern about how they work? Well, the numbers are either getting bigger or smaller, and they're getting bigger or smaller by the same amount every time. So in other words, what we do is we add, okay, the same number, even if it's negative, to make it get smaller. So we add the same number every time to get the next term. And since the difference between every pair of terms is the same, then we call this a common difference. So let's write the word common right here. We call that a common difference, and we give a special name to that particular type of sequence. We call that an arithmetic sequence. So arithmetic. Okay, we pronounce it a little bit differently again because it's an adjective. So let's see if we can figure out a formula for these arithmetic sequences. So it says answer the questions using the given arithmetic sequence. So this is an arithmetic sequence. It's going from 4 to 7 to 13 to 10 to 13. So what happens here is we're going up by 3 every single time. So the common difference is 3. So let's just write that down. And then off to the side over here, it says you can find the common difference by taking any term and then subtracting the one before it. So I can take any term, let's take 13, and then subtract the one before it. That would end up being 3. I could take any term, let's say I take 7, and subtract the one before it. I end up with 3. So 3 is the common difference. Now here's where we get into the interesting part where we can figure out the formula. It says how many common differences are there between A1 and A2, so between the first term and the second term. So how many common differences are there to go from 4 to 7? Well, just one, because we add 3, so there's just one common difference there. Now, if we want to go from the first term to the third term, so the first term to the third term, we have to add 6, so that would be 2 common differences, because 2 times 3 is 6. And then if we want to go from the first term to the fourth term, so we want to go all the way to here, we would have to add 9, because 9 plus 4 is 13. So that would be 3 common differences. 3 times 3 would be the 9, so it's 3 common differences. So if we're on the nth term, we start with the first term and then we have to add. Notice if we're on the fourth one, we had to add 3 common differences. If we're on the third one, we had to add 2 common differences. And if we're on the second one, we only had to add 1 common difference. So if we're on the nth term, we always take that and we subtract 1. and we have to add that many common differences. And I'm going to put that in parentheses, and you'll see why here in just a second. So if we're on the nth term, we take the first term and we add n minus 1 common differences. So here's what we've got, a general formula for an arithmetic sequence. Again, general formula, nth term formula, explicit formula, all the same thing. So this right here is the nth term. And then this is the first term, and then that d right there is the common difference. Common difference. Okay, that's how much there is in between each one of the terms. So we take the first term and then we add n minus 1 common differences. So let's see if this works right here. If you take the first term of 4 and then you want to get the fourth term, so you would add 4 minus 1, so that's going to be 3 common differences. Well, the common difference on this one is 3, so that would be 4 plus 9. We end up with 13, and we do indeed get the fourth one there. Okay, so we usually simplify these formulas once we plug all the numbers in, and you'll see how that works in just a second. I'm going to slide down here, and let's talk about how we can get a recursive definition. So on a recursive definition for an arithmetic sequence, normally they give us just the first term. And now you'll notice that I didn't put a 1 down here. So you'll notice that sometimes the first term is denoted just with an A, kind of like we did right here, or like this. We could just get rid of that 1. And it's kind of the same as when we write down an X. Everybody assumes that it's a 1X. So if there's no subscript, if there's no index there, then we assume it's the first one. Now, like we were talking about before, this is the next term. So A sub n represents the next term, and A sub n minus 1 represents the previous term. And there's usually not a whole lot of simplification that we can do with a recursively defined formula. As opposed to a general formula, then we do some simplification. So here's what we're going to do for the next little bit, and this is more like what you're going to see on your assignment. It says find a general formula and a recursive formula for each arithmetic sequence. And sometimes it's helpful to write out several terms just so you see the pattern and stuff like that, and make sure that your formula actually does what it's supposed to. So here's what we're going to do. We're going to write down the formula. So this is going to be A sub n equals, and then we slide up here so we can see what that formula is. So it's the first term, so this is going to be 10 plus n minus 1 common differences. And then in this case, the common difference is negative 11, so I'm going to put that in parentheses. And then we do some simplifying. So we're going to distribute through. So we're going to get A sub n. Oops, let me do it over here. So this is going to be, let's see, we've got a 10 and then minus 11n and then plus 11. So if you put the two of those together, we get 21. So I'm going to write down A sub n equals negative 11n, and then I'm going to add the 10 and the 11 together, and we end up with 21. So this is the nth term formula, the general formula, the explicit formula for that sequence right here. And then it says also write down a recursively defined sequence for that one, a rule for that. So we're going to write down A is equal to 10. So we're going to write down that the first one is equal to 10. And again, I could just leave that A, or I could put a 1 there. And then the cool thing about recursive formulas, they're a pain in the butt to use, but they're actually pretty easy to write. So we write down, okay, I need the next one, and I'm going to use the previous one. So this is going to be A sub n minus 1, and then we just write down plus whatever the common difference is. Well, in this case, the common difference is negative 11, so I'd write down plus negative 11. Make that look right there. So plus negative 11. But it's normally easier just to simplify this a little bit, because a plus, a minus is just going to be a minus. So I'm just going to write down minus 11. So what we do here is we start with 10, and then we're going to subtract 11 every single time to get to the next term. So if I were to write out a couple of these, I'd start off with 10. And then this says, to get the next one, I take the one before it and I subtract 11. So this would be negative 1. And then I'd take the one before it and I'd subtract another 11. Again, to get to the next one, we take the one before it, the previous one, and we subtract 11. So this is going to be negative, what do we get there? Negative 12. So if I want the fourth one, I take the third one and I subtract 11 from it, so I end up with negative 23. So let's just see what happens if I want the fourth term. So this is the fourth term. I'm going to plug this in to the general formula. So I'm going to plug it in right here. So A sub 4 should be negative 11 times 4 plus 21. So this is going to be negative 44 plus 21, and we do end up with negative 23. So these match up. Okay, so it does indeed work. Now, you don't have to do that every single time. All you need to do is write down what the formula is. So let's take a look at this next one. Again, this is problem B, so we're going to use a B to write down the formula. So B sub n for the general formula is going to be the first one, so that's going to be 2 plus n minus 1 common differences. So the common difference on this one is 5. So you'll notice all I'm doing is I'm just replacing each time I have a value. I need the first term, so that's going to be a 2. This is n minus 1, and then I put the common difference of 5 right here, and then I'm going to distribute through here. So let's see what we end up with. We end up with a 2 and then plus 5n and then minus 5. Those two are like terms, so here's the nth term formula. I end up with 5n. So we'll put 5n right here, and then minus 3 when I put the two of those together. Okay, so there's the nth term formula. And now we'll do a recursive definition. So this is going to be b is equal to 2, so that's the first term. And then again, all we're going to do is we're just going to write down this formula. So to get the next term, we take the one before it, so that would be a subscript of n minus 1, and then we're going to add the common difference, and the common difference in this case is 5. So that's it right there. Again, you don't need to check every single time. I just want to show you that that actually works. So we're going to slide down here, and we're going to do the same thing again, but this time we've got different information. On example 4, we were actually given what the first term was and what the common difference is. Here, we're just given what it looks like, and we've got to work out what the common difference is. And we still need to write a general and a recursive formula. So on this one, you'll notice this is the one from up above, so the common difference is 3. So let's go ahead and write down that formula. Again, the nth term formula is take the first term, so that's going to be 4, plus n minus 1 common differences. So the common difference is 3. So again, I'll say that a whole bunch just because it's really useful. We take the first term and we add n minus 1 common differences. So if you have the first term and the common difference, you've got the formula pretty much. So we're going to do 4 plus, we distribute that through, so that's going to be a 3n minus 3. So we end up with a sub n is equal to 3n. We'll write that term first, and then this is going to be plus 1. We go ahead and circle that, and we've got our formula. The other way to do it as a recursively defined formula is we'll write a is equal to 4, and then we'll write the next term. We find that by taking the previous term and then just adding the common difference. And in this case, the common difference is positive, so we're just going to write plus 3. We circle that, and we're done. Now let's take a look at the next one. We start off with 55. So again, I'm going to do b sub n is equal to the first term plus n minus 1 common differences. Now, we need to figure out what the common difference is here. So we take any term and subtract the one before it. So I'm going to take 37, and I'm going to subtract 43, and we end up with negative 6. Now, just as a double check, I'm going to take 43 and subtract 49, and I end up with negative 6. So the common difference is negative 6. Now, because that's negative, I'm going to put that in parentheses, and then I'm going to distribute through. So let's see what we get here as we go through and simplify. So we get 55, and then negative 6n, and then plus 6. So the nth term formula here is going to be 61, and then minus 6n. Now, you'll notice that I wrote this in the opposite order. It's totally okay to do that. We do normally write it this way, b sub n equals negative 6n minus 61, just because it's a little bit more conventional to do that. We normally write the variable term first and then the constant at the end, but either one of those would be okay. So let's take a look at the recursive definition for this. So the first term is 55, and then we write it down the same way every single time. The next term is equal to the previous term, so that's b sub n minus 1, and then plus the common difference. But in this case, the common difference is negative 6, so we're just going to write minus 6. So we take the previous term, subtract 6 from it, and you'll get the next term. So when the common difference is positive, the numbers are getting bigger, and when the common difference is negative, then the numbers are getting smaller as the sequence goes by. Oh, and before we move on, I want to catch a mistake that I made right here. When we put the two of those together, we get plus 61. So let's go ahead and fix that right now. The rest of this is good, and let's take a look at example 5 star. So based on these examples up above, based on these sequences up above, it says find the indicated term for the sequences up above. Which would be better, a general formula or a recursive formula? So if you want to find a sub 102, so this is the 102nd term, and this one's the 35th term. Notice they just put n equals 35 here. Well, in order to find the 102nd term, if you were to use a recursive definition, you'd have to find the first one, second one, third one, all the way up to the 101st one so that you could use the 101st one to find the 102nd one. So we're definitely going to use a general formula right here. So here's what we're going to do. We're going to plug in a 102 right there. So the subscript here is 102, and that means that we're going to plug in a 102 right here. Now, sometimes people get confused and they figure out, well, when do I just make it a subscript and when do I use it as part of a math problem? Well, this is 3 times n right here, and you'll notice that this is not a subscript. This isn't 3 sub n, it's literally 3 times n. If you have to put a dot in between there, go right ahead. So we end up with 3 times 102, that's 306, and then plus 1, so we get 307. So the 102nd term is 307. So I'll go ahead and circle that right there. And then on this one, we're going to plug in a 35. It's 35 to the nth term formula. So we're going to do the 35th term is equal to -6, and then we're going to times that by 35. Times that by 35, and then we're going to add the 61 right here. So negative times positive is negative, and let's see, 6 times 35, 2 times 35 would be 70, so I think we're going to be, that's the same as 3 times 70, so that's going to be 210. Double check me on your calculator, and then we're going to add 61. So we'll combine those together, and let's see, we'd have a negative, let's see, I think that's 149. 149. So that means the 35th term, b sub 35, is equal to negative 149. We'll go ahead and circle that, and we are all set with that one. Now this one says, complete the statement for the arithmetic sequence. Negative 203 is the blank term of 55, 49, 43, 37, and so forth. So it's this one right here. So this is a little bit different. They've given us the term, but we don't know what the index is. Now again, the best one for jumping around from any term you have to whatever you need or whatever is going to be the general formula. So let's find the general formula for this one right here. So that is b sub n is equal to negative 6n plus 61. And what we're trying to figure out is they've given us that this term is negative 203. So I'm going to put a negative 203 here. And then what we have to do is we have to find out, well, what number did we plug in? Because if you can find the number right here that gives us that one, that is the index. That's the counter, and it'll tell us which term it is. So we're going to add 61 to this right here. And then we solve this just like we would a normal equation. So we're going to subtract 61 from both sides. So we end up with, this would be negative 264 equals negative 6n. So then we're going to divide by negative 6. And let's see, we end up with n is equal to negative 264 divided by negative 6. That's going to be a positive. I'm thinking that is 44, but let's pull up the calculator and let's check and make sure. So negative 264 divided by negative 6 equals 44. So that means the n that we plugged in here had to be 44, so that means it's the 44th term. All right, lots of stuff going on there. That's your first introduction to sequences. A lot of work. Please make sure you pay attention to the details, ask if you have questions, and good luck on the assignment.